Hey YouTube, welcome to another video. In this episode, we will discuss more about the ACL. In the previous episode, we have implemented this design. So, the NewGen LAN. If you're new to networking or Omada, or if you're not familiar with the term VLANs and SSIDs, I highly recommend that you watch the previous episode because I have gone through explaining a lot of it and I have shown how everything is wired up and connected together and how everything is configured. But one thing that I would like to go through in this video is address a different use case which this current design in the previous episode did not address. What I mean by that is that in the current implementation of the configuration of this design, the home PC can access the IoT VLAN. As you can see here, the home can access other VLAN. However, the IoT cannot access the other VLAN as well. Meaning there will be two-way communication so long as the initiation, the start of the communication starts from the home VLAN. So that's how the Gateway ACL is implemented currently in TPLINK. But there is no way for the Raspberry Pi to initiate the communication back to this particular VLAN. So that use cases, for example, is if there is a server here in the home VLAN that you would like your Raspberry Pi to access. And I'll give a good example is the DNS server. If you would like your DNS server to be accessed by the Raspberry Pi using the current implementation and configuration in the previous episode, that cannot be done. The only way to go through that is through the Switch ACL, and that will be the focus of this episode. Let's continue with the configuration, but before I go do that, okay. Also in this particular episode, I will also discuss one thing that I missed covering in the previous episode, which is how to do reservation IP, because we will have a DNS server and you would like to have your DNS server to have the same IP even after it's rebooted, so it will always have that same IP address. Also in this particular design, you can see here there's a granular access here. I guess this one will be 6, so IoT will have some granular access to the other network. So let's go through the configuration. I will start first with the reservation IP. Okay, so in order for us to do that, let me just demonstrate it here. To reserve an IP for this one, for the Pi-hole lab, all you have to do is here, because this is our custom DNS server. Go here, click here. This is currently in the home VLAN, VLAN 10. 168.10, and I'll choose 75 just because the DHCP here in all the VLANs, all the non-native VLAN will be starts at 100. So I think for the servers, anything that's reserved is below 100. I think that's a good idea for this one. Okay, so click apply, make sure I click apply, and let's connect to that server. Pi at 2.168.10.102. So as you can see, this is the Pi-hole lab 102, and I would like to reserve a 75 IP for this one. And in this particular use case or scenario, I have finished updating the server and now I'm rebooting it. Or you can say that there is a power loss and now the server is rebooting. Okay, so 68 and 75. So I'm pinging it here like this. As you can see here, since it's currently rebooting, there will be a request timeout, but it should, when it come up, it should be 10.75, and we can see that later on. Let's do the same thing for the controller. Okay, for the controller, I assign a fixed IP, and since I'm already using it in here 0.100 at the admin VLAN, and also this one is not for the usual clients anyway, So I'm okay to reuse the same thing in here just to make sure that you don't have to reconfigure or reconnect to the admin and to the Omada controller and configure it again. One thing that you can check, one way you can check whether where your reservation lies is in here. You go to services and go to IP Reservation, and from here you can check your reservation. Let's add some from here. Add for DNS, and this one will be your Omada controller. Okay, and let's check this again. Okay, there you go. In here, that means the server has come up. Okay, let's control break this one. Swatch here. It's the view how it goes. So I was pinging it continuously. It wasn't, it was rebooting, and then it was slowly coming up. And then when it came up, it got the new IP address reserved by Omada, as you can see here. And we can verify that by going to your clients and look for the pi-hole lab, and that's it. So that's about it for the reservation IP. So now let's go through the main reason for this video, which is to have a more granular control over your network. Okay, so let's just revisit it again. Currently, home can access Raspberry Pi. They can initiate the communication, and let's go through that. Let's see here. For this particular video, I separated one machine in the home VLAN to mimic the home VLAN computer, and I will also connect it to Wi-Fi for this particular recording PC. This PC is the admin PC. Is the one that I'm currently using is the admin PC. It's currently I believe this is 104. That is 104. That's correct. So this is the admin PC. And I also have one in the 107.100, that is the IoT device VLAN. So currently the way it works is I connect here, I can connect here without issue, connect here, and then I can connect here without issue. And that's to the Gateway ACL. However, that SSH pi at our pi here, SSH here, 192.168.107.100, it should be able to go through because home can get through IoT. And as you can see, I was in Pi machine, now in Pi desk. So I cannot do that here. Pi at 192.168.10.101. So this is the IP address here, 101.101. I shouldn't be able to do that because of the Gateway ACL. As you can see here, it's not allowed. Okay. So again, if I IP add here, you can see I'm currently at the 107.100. I'm in here, and if I exit, I'm back into my home machine. Okay, IP add. And you can see I'm in my own machine. So these machines are in different VLAN. The home can access IoT. The IoT cannot access here. Okay. Like I said, if I have a custom server in the home VLAN, there will be a change in the configuration. Let's go do that. So put security. So you can see here the Gateway ACL, we don't have any Switch ACL, we don't have any EAP ACL. And the main ACL that is allowing us to communicate from home to IoT is this particular one, preventing IoT from communicating to the home VLAN. Okay, because it is denied for everything else. Okay, so let's disconnect that. Okay, so now there is no rule. There is no rule that is preventing IoT from accessing the home VLAN. So if I do the SSH here, it should work. There you go. And this shouldn't be affected. It's always working. Okay. So just a quick check that without the ACL. Now I have to go do that here. Create, deny IoT to all. So all. Okay. So IoT, and then I will have to select all VLANs. Remember, if I do that, look at what's going to happen here. Okay. before I have a similar capability, right? I mean similar, not the same, similar ACL. This one, it's deny LAN to LAN network to all the other VLANs other than the IoT. I will have the same thing here, similar thing. Keep saying the same. I should have the same thing. But the impact of that particular command will be that I lost access. As you can see here, I lost access to my IoT because now there is no more stateful connection that maintains the connectivity between the admin VLAN and this network in the home IoT VLAN. Because of this switch ACL, I'm completely blocking all traffic going to that particular VLAN, the network IoT VLAN. Okay, so to simulate the home connecting to this one, right? So I will connect to my house Wi-Fi. That will give me home VLAN IP. Okay, now I'm connected here. So what that just means is that we need to create a new, and again, this is the main reason why Gateway ACL is really good, because it's it's a quick and dirty way to implement one-way stateful ACL. Okay, permit VNC, permit, so then I'll say network group, create IoT VNC port. 7.1, 4, 800, 800. So let's do that. Did that work? Permit VNC to IoT. Okay. Oh, should be okay. Should be to home. Okay, hold on. Home, because I would like I will be at the home VLAN. So IoT. So this one has the IoT VNC port. You should be able to send data to home, basically is what we're saying. Okay, create. And you have to be very careful here, because in here, as you can see, it will still not work. No, it will still not work, because the order of the role is important. So of the ACL. So in here, okay. So now I'm allowing home. So let's just make sure I'm connected to the home. I'm connected to the home. Okay. Now let me disconnect to my wired network here. Disable. There you go. Okay. I'm in home. So I'm trying to ping the Omada controller from home, this one. As you can see, I cannot ping it because now I'm currently in the home VLAN. But I will still be able to maintain my connection here because this one is in home and I'm in home. So let's see, 10. Yep. Now, so because of the rule that I have here, I should be able to connect there. And there you go. Okay. So this is just the VNC. As you can see, this is a more granular approach, meaning for now the communication between home and the IoT is just through VNC. If you would like to enable other protocols, you have to make sure that you define that for IP port group. The similar thing that I'm doing here. I permit the VNC, and let's do that again one more time. Okay. So let's SSH to this IoT. Previously with the Gateway ACL, we can do that pretty easily without any problem. Now we can do that. Now SSH pi 192.168.10.101, and as you can see, The IoT still cannot initiate the communication, but biggest difference is that this one still cannot initiate the communication between the two as well. So like I said, we allowed VNC, now we need to allow SSH. So let's use that as another example. But now in order for me to do that, I need to go back to the VLAN so that I get full access to the admin, to the Omada controller. So it should list out all the 4. There you go. Now I should be connected to. Okay. So now the next thing to create is the SSH. So permit SSH to IoT. Oh, look. IoT SSH port. Same. So I need to SSH port. Let's say I would like to SSH from the network. I can do that too. I can just do that. Or I can also do that. So for now, let's just for the purpose of discussion, let's just do this. Great. So it will still not work, like I said, because of the way the order of ACL is being shown right here. So let's see here again. Let's demonstrate that. Cannot. Let's see here. Let's see here. There you go. You can see here that I've got a prompt here. So if it's not very apparent, let me try it again. Let's see here. There you go. It's still not working here. There you go. So in these situations, this server, the VNC server, is in IoT. It's already defined here for the VNC, and the SSH server is also running on the Pi. So I was able to, connect here from home, and I defined it that I'm connecting it from home. Now, other than the VNC and SSH, these are the only ports that are allowed going to the IoT. So if you have other ports, like I mentioned, that needs to go through, you have to keep adding them here on top, followed by the deny as the most bottom index, so that they don't get in the way of declining or denying all your traffic to the IoT. Okay, so let's do just that. Okay, okay, Control C. So one of the use cases that we would like to address here is using a DNS server, custom DNS server for your IoT. So I have installed NSLookup here. Well, DNS utils actually, to be more precise. So I can have, so if I go google.com and I go the same thing here, google.com. Remember, these are different VLANs. Their DNS server is their own respective gateway. Okay. Now I have a custom DNS server that I mentioned earlier, server 192.168.10.75. That's our AdGuard server. Now if I do the same thing here, google.com, it will use the AdGuard server. You can see here 192.168.10.75, and it gave a different answer, but this one should not be able to provide reply because I'm not allowing any DNS port 53 to go through the network. As you can see here, this one will not work. Okay, so for the last portion of this video, let's so we have the DNS server in the home VLAN. It's currently in the home VLAN. Okay, so that will be our destination from IoT. Okay, so let's create another one. So another permit. It's a permit DNS port to home. So rather than the DNS port to your respective gateway, permit DNS port to the home VLAN. Okay, so IoT group. So what is my home DNS? let's call it DNS server instead. And I only want one DNS server, so I'll use a /32 port 53, so that even if I have 10.1, they will still, the IoT still cannot use that, but instead it can only use the 75, cannot use the other DNS server that I might have in that particular VLAN. Okay, create DNS server. Okay. Create. Okay. Again, it will still not work for the time being. As you can see here, it still works in the home, but you can see here it's not working here. The only way for me to make it work is if I rearrange this ACL. So before we do that, let's check here. Make sure not the it's blocked there. Let's do this. Make this port. And let's do the same thing. I should still be able to do it here at the same time. And there you go. In here, as you can see here, that my server is the 192.168.10.75, that I'm able to use the DNS server. So this way the communication goes from IoT to the client PC. Okay. So that's pretty much it for this part of the video. We allowed the communication from home to IoT in a more granular way. Okay, thank you for watching the video. Till next time, bye bye.